Oh, I want to fix the roads, like people are complaining that our roads are bad, or I want to do my drainages. There's a demand from someone, and then when the demand occurs, you don't just jump into the project.
Sorry for interrupting your class. Style. So I just discovered that we didn't start the recording, so we started a bit late. So everything you said, you can just probably give like 2 minutes summary, so that when they are watching back, they can actually. Thank you so much, and I'm so sorry. I'm really sorry. God bless.
Everybody should please go and read the material. I would run, the summary will come from here, but I can't go back to the beginning. I've said a lot and I was just saying a lot of it from my head. The summary was definition of the project, properties of a project, and then criteria for selecting a project, and then the stages involved in a project. So the stages, we spoke about proposal, we spoke about your evaluation, your implementation rather, and then we are speaking about, I can't remember the last one, you've thrown me off course. We're talking about the proposal, your authorization and implementation. Yeah, I remembered. Then, as I was saying, for the project cycle, when we're talking about the project cycle, every project starts with a demand. And then when you have the demand, you cannot just jump into the project. You need to study. You need to look at, okay, what do I need to do to execute this project? How am I going to go about executing this project? That's where the study comes in, and research. And then when you have a study and research, you can develop the project. And then that's why you see after development, which is where is the iterative project between, iterative process between your conception, which is the ideation stage, and the evaluation stage. So immediately after your development, you move to your design. But then you can see after study, you have evaluation. Like I said, you need to check, okay, my environmental impact analysis, this location that I feel I said is going to work, is it really going to work? The equipment, the outputs, are they going to be delivered? Do I have enough funds for this project, for price estimates, for working capital? Do I have, is my estimate well defined, stating both local and foreign goods? The environmental impact analysis, okay, this project, what's going to be the effect on every other person living in the area and the surroundings and on the environment itself? So all of that's in the evaluation stage before you now actually move to design. So your evaluation stage runs concurrently with your research and development. Like I've been saying, it's an iterative process, and all of them will eventually end up, when you find a suitable one, in your design stage. During your design stage, after you've decided on a suitable design, you make orders for your supply for different construction materials, raw materials that you'll be needing for the course of the project, and then you can actually start your manufacture and construction. Then after that, you move on to commissioning of the project and use of the project. Then you can see a dotted line. The dotted line occurs after is like posts, after the project has been completed. So after use, you have maintenance, and then based on whatever is happening, you have your experience and record. So that means if I create a retaining wall now, and then we've started using it, we're maintaining it, but at the same time, we're also going to be taking records of, what we experienced during rainy season, what we experienced during dry season. Is there a crack that developed after 10 years? All of that is going to be put there. So when next someone wants to do a project similar to that, it is based on the experiences and records of the past that they will use to improve on the structures for the future. I hope you understand that. So that's where the project cycle comes in. So I'll be moving on. I've explained all of this. I've run through this. So yeah, I mentioned the marketing, technical appraisal, marketing appraisal. So we move on to the financial appraisal, which is one of the most important. I think I need to mention that there are two types of projects. A project can be a commercially based project or an amenities project. So when we're talking about commercially based projects, we're talking about projects that must yield return. We're talking about profit-based projects. And for those kind of projects, when you're doing the evaluation, you're looking at the return period of the project, the payback period of the project, and how much profit the project is going to return. But when you're talking about your amenities project, these are not profit-based projects. These are projects that are done on the basis of people's needs, usually by governments. Let's say they want to build a new road because the road, the members or incumbent members of the areas are complaining about the road. That kind of project is an amenities project. It's a service project. So that kind of project, you're looking at minimum costs. minimum cost considerations. That's what you look at for your evaluation. And the evaluation is not as simple because you're not just trying to determine a payback period. So moving on, if you're talking about your financial and profitability consideration, but considering projects this time around that these are commercial projects, whereby the return you're expecting to make would be made medium or long term. So what do I mean? There are some projects that as soon as you're embarking on them, you're expecting that as soon as you deliver your output, your return is going to come. But then there are some projects that your return will not come until for a couple of years, like you're making an investment down. For example, I'm buying a piece of land and I'm waiting for the land to appreciate before I sell it. It's a long-term investment. I'm not expecting to buy the piece of land today and make my money back tomorrow. So those kind of projects, you're looking at long-term or medium-term projects. The reason why I was specific about long-term and medium-term projects, because those are the type of projects where you will now need to determine the time value of money. What do I mean about the time value of money? If it is a short-term project, the value of money will not have changed between today and tomorrow, most likely. The chances are very low. But if we're talking about something of 10 years, 15 years, the value of money today will not be the same value of money in 10, 15 years. So when you're doing your estimates, your forecasts, your prediction on the profitability, you're not going to be using the value of money today. You need to consider the time factor. So for those kind of projects, we're considering there are two techniques. The first one is your internal rate of return, and the second one is your net present value. So for your internal rate of return, I don't know how many of you really paid attention during CEG510 last semester, but we came across it. In that situation, your internal rate of return is when the interest rate would allow the net present value to be equal to zero, where we would do an iterative process until you get an NPV, you get your value of I, where your NPV will be equal to zero. We call that point where your NPV is equal to zero a break-even point. Your break-even point in layman terms is the point where your total cost and your total revenue curve intersect each other. That's for internal rate of return. We will not be talking about it obviously in detail because it's not part of the scope of this course, but I'm just mentioning it. Should, in case you see it, you can have something to say. So as you can see, this is a graph. On this graph, you can see your costs and your time and your revenue. So if you look at your costs, everywhere your total costs intersects your total revenue, you have a break-even point. You have your B2, you have your B1, and your B3. So those are your break-even points. So everything above your break-even point is positive, and everything below your break-even point are negative. So this is profit, this is loss. I hope that makes sense. Then we move on to one of our major focuses of this class, which is our MPV. So for this example, this is not the main example, but I will just simply explain to you. So in this situation, we have certain steps we're trying to follow. We are trying to determine our present value worth, and we would have an investment. We will also be given, we'll have an investment. We'll also be given the value currently, the total, the income. Yes, that's the word I was looking. So we'll have the cost and we'll have the income. So we'll be using our present value factor to get our total present value. All of that will make sense too. So we'll be, first thing you need to know is you'll be getting your PVF, which is your present value factor. And after getting that, you'll be using it to multiply the net income, which is the value that will be given to you. So it's simply like we're talking about compound interest, is compound interest, where they tell you, oh, you have a man puts 1 million naira in the bank at the rate of 5%. So how much will he make in 5 years? So this is the income we have. Project cost is our capital outlay. So what we are trying to determine is what we'll be having after 12 years, what we'll be having after 12 years with 12% interest is the same thing. So I'll be switching to whiteboard now and we'll be solving this particular question. He didn't give us a specific written word, but according to previous past questions, you'll be given a table. On that table, you have certain things when I mean certain things, you'll be giving your net income for 2 or more projects. The idea is to compare your present value and profitability index of both projects to determine which project is more commercially viable and profitable, and make recommendations on which one should be invested in. That's the summary of what we're doing over here. So let me quickly switch. Please excuse me. I hope I'm not too fast. Stop sharing. Okay, so the question is in the slide. I don't think I want to repeat the question. You can simply open the slide on your phone. I can give you like 2 minutes to do that. Please let me know as soon as you've done that, so we can all be on the same page and you can be looking at the question at the same time. Can I proceed? Nobody's answering. Can I proceed?
You said 2 minutes. No.
Okay. All right, so I think my 2 minutes is up.
Yes.
All right, so let's proceed then. So I would be withdrawing the, do I even need to withdraw it? Okay, I will be withdrawing it for clarity's sake. So let me just get on that immediately. So we have our year. We have present value. Then we have project A. Okay. So we have here year. Then here we have 1, 2, 3, 4, 5, 6. Then we have PVF. PVF means present value factor, please. So whenever I say PVF, I just use it as a short form. PVF in brackets, 12%. Just ignore that, please. Then here we have, okay, so the PVF is what we're going to be calculating first. That's the first thing you need to do. You need to get your present value factor. But in your question, let me just write it out once and for all. We'll be having our, we'll be giving our net income for each project. So for project A, we have 1,000, 5,000, 4,000, 3,000, 2,000, and 1,000. Please be checking the values to ensure that I'm not writing nonsense. Just in case, if I make a mistake, please call my attention to it. Project B, we have here we have 2,000. We have 8,000, 6,000, 6,000, 6,000, and 4,000. All right. So this is what we'll be giving, and we would also be giving our net project cost. So let's just have it somewhere here, just by the side. The net project cost given is for project A. So let me just put A is equals to 10,000. And B is equals to 20,000. So these are the parameters you expect to be given in a question, in a regular question, yes. So you have your year, you have your present value factor interest rate, you have your income, and then you have your costs. So the first thing you need to do is calculate your present value. And let me just put this by the side too. The formula for your present value is equals to PVF. Again, I said present value factor is also known as PVF. So your PVF is equals to 1 all over into brackets 1 plus I raised to power n, where your I is your interest rate and your n is equals to your number of years. So from this, we have everything we need to calculate our PVF here. This is your year, this is your n, and we can calculate your PVF. So if you punch it on the calculator, what do we have if we do 1 all over 1 plus I raised to power n? We should be having 0.2928929. Please, can someone confirm it? Please, it will be easier for you if you follow the class.
Sure.
Yeah.
Sorry, can you just repeat that? You kind of like passed just the values you just called them.
Okay. I said the first thing you need to do is calculate your PVF. And I wrote on the side the formula for PVF is equals to 1 all over 1 plus I raised to power n. And then I went further to say that your I is equals to your interest rate, which has been specified here as 12. And n is your number of years, which is what we are given in this column. So for the first row, I said, what will be our PVF? You slot in 1 and you slot in 12. What would be your final answer? I was now going further to say that it would be in your best interest to follow in this class by punching in the values and getting answers so that you will remember easily. So I said, when you punch in those values for the first year, you should be having 0.8929. And I said, someone should please confirm that that's what they got. And nobody responded. So I assume we're not punching it in our
That's it. That's you are correct.
All right, thank you. So we should be having 0.8929. That's where that PVF factor came from. I hope you're all with me and we're still here and you're following. So if you repeat it for the second year, what do we have? Okay, since it's taking a lot of time.
0.7972.
All right, thank you. Third year.
0.7118.
Fourth year.
0.6355.
Fifth year.
0.5674.
And 60.
0.6. So 0.5066.
I hope we punched this on the calculator and we all got these values. So I will be working with these values because these were the values that were supplied to me. I don't know if they are right or wrong, but I hope they are right. So the next step after getting your present value factor using your interest rate and your number of years, you need to multiply your present value factor by your net income to get your present value. So I will write the formula here just so you can understand what I'm saying. We said your present value is equal to your PVF times your net income. So for project A, the next step is to multiply 0.892 by 1,000, and that should give you 892.9 or 893. Do we all get that? Are we all still here?
Yes, ma'am.
Then for the next one, we should have 3,986. And for the third one, you should have 2,847. Fourth one, 1907. Then 1135507. So that's where all these values came from, by multiplying the present value factor by the net income. Then we move on to project B. We're going to be multiplying this same present value factor by the same net income to get the corresponding present value for project B. So here we have, if we have 0.8929 multiplied by 2,000, it should be giving you 1,786. Then the next one, 8,000 times 0.7972 should give you 63,078. 6,378, and so on and so forth. But just for clarity's sake, let me just input it. 3, 4, and the last one is 2026. All right. So at this point, we're halfway done because we've gotten the key players to completing the game. So the next step now is to total your net income and total your present value. So can someone add up the present value of A and someone add up the present value of B so we can have our total present value? TPV is total present value. So let's just have that here. That's TPV. So what's the total present value of A, please?
11,205.
11,000 what?
205.
275. And for project B?
21,678.
21,678. All right. So now the next formula you need to know here is to get your net present value, which is one of the key factors to determining whether your project is worth or worthy to be invested in. NPV is equal to your total present value minus your project costs, or it might be investment, or it might be outlay, whatever English term they call it, it is still the same thing. So I would write it here once again. NPV, which is your net present value, is equal to your TPV minus your net project cost. So let me just put it here. We have our project cost for A as 10,000 and our project cost for B as 20,000. So you input that on your table. So we have our project costs. I will just call that PC. And here we'll just input that quickly. So it will be easy. We can just have 10,000. And here we have 20,000. So as I was saying, our NPV would now be equals to 11,275 minus 10,000. So that should give you 1,275. And then we have the second one, which is 21,678 minus 20,000. So that should give you 1,678. So that is our net present value. So we've gotten our first major factor. Then the second thing is your profitability index. Your profitability index, which I'll be calling PI, is equal to your TPV over your PC. Simple and short. So we have 11,275 divided by 10,000. Please, what would that give us? Please, can someone supply the answer? What's the answer? 11,275 divided by 10,000. Wow, nobody's responding. Okay. 11,275 divided by 10,000.
We were doing it. Calm down.
Is 1.13. All right. So your profitability index here is 1.13. And then for B, you would have 1.08. All right. So here we have our NPV. We've gotten our NPV and our profitability index. So the final step is to compare the two of them. So as we can see, project B, right? Yes. Yes. Project B has a higher net present value times than project A, but project A has a higher profitability index than project B, which means project A is more profitable than project B. Therefore, you should go with project A to be invested in. But take note, your
please come again with the explanation. As in, you just they go like the explanation.
Your profitability index, you're to select the most commercially viable, the most profitable one is the one with the higher profitability index. Are you with me? So project A has a higher profitability index than project B. So therefore project A should be invested in. That's what I said. That's all I said. Are you with me?
Yes, I'm sure.
So I was trying to explain something further. Now, for any business to make profit, it must have a profitability index greater than 1. Any project in which you get the profitability index that is less than 1 is running on a loss. So in a situation whereby after calculation, the two of them had profitability indexes less than 1, you need to specify that both of them are losses and that you recommend none. but that should the clients be willing to go for it, you will now recommend the higher of the two. Do you understand what I'm saying? Or should I come again?
Yes, we understand. Yes, we understand.
Okay, so the the project with the higher profitability index is the one you recommend as should be embarked on. But every project to make a profit must have a profitability index of greater than 1. Any project with a profitability index of less than 1 is running on a loss. So that is all about net present value worth, and net present value worth, and all of that. So if we have time, I would solve one more question, but I feel like I did justice on this question. We took it step by step and I evaluated all the necessary formulas. So even if we do not solve any question, just follow this same process. He doesn't go outside of this. Just follow this same process and you'll be fine. It may be 3 projects, it may be 4 projects, still the same process, and get your net present value, get your profitability index, and recommend the most commercially viable one. So I will move back to the slide. That's 1 out of 2. So yeah, we moved on to the next one. We were talking about construction project teams. And here we mentioned that civil engineering is the oldest branch of engineering, and civil engineers are constantly involved in one project or the other. And then we went further to say that construction projects can be classified as building projects or civil engineering projects. What differentiates a building project and a civil engineering project are the clientele involved. If it is a building project, you have the clients, the architects, your engineers, which include mechanical, electrical, civil. Then you have your estate managers, you have your quantity surveyors, you have your project managers, you have your contractors and interior designers. But for a civil engineering project, you have just your clients, your engineers, your project manager, and your contractor. So for you to consider the roles each personnel is to play in the project, it depends on what stage of the project it is. So we have your design stage and your construction stage. So during the design stage, the role of the architect is to design the building. The role of the civil and structural engineer is to create the detailed design for steel members or reinforced concrete members or precast members. And your service engineer, you're talking about air conditioning, lifts, lighting, and all of that. Landscape architects, you're talking about acoustic services, sanitary work. And you have your interior designers, obviously, you know what those guys do. They design the interior of whatever structure it is, make it homey and beautiful. Then you have production engineers, you have your clients, you have your quantity surveyors at the design stage, just ones that estimate the quantity or the bill of estimates of the project to be embarked on. Then this is an example of a construction team. So in the construction team, you can see you have your clients. Then when you have your clients, the first point of contact is with the quantity of surveyors, which is going to provide the project cost, and then with the engineers, architects, special consultants, which are going to provide the designs for the structure. And then outside this team, which is the construction team, you now have your estate surveyor. The estate surveyor is to provide value of the lands to be developed on. Then once these two have done their job, they are to select the main contractor who is going to actually erect the structure. And then the main contractor selects a nominated subcontractor or a regular subcontractor. So then the other one, there's a second one. This second one is a contractor relationship between all the parties to a contract. So the client is the one with direct contacts to this quantity surveyor, with direct contacts to the special consultant. It's also the one with direct contacts to the engineers and architects. Then the engineers and architects select a contractor. That's when it becomes nominated. The client can also select a contractor and is also nominated. Then you have this contractor is the one that selects the subcontractor. Then the client is the one that selects your estate manager. So that's the charts. Those are the two charts. Please look at them. Then we have the clients. The role of the clients is the fund money bank. He's the one that provides money for throughout the progress of the project. The architect is the one that determines what is exactly is going to be implemented on site and supervises the quality that is achieved on site. Then he's also the one that approves the payment to the contractor, but he's not in the position to tell the contractor how to carry out his job or how to go ahead with the construction. So the architect tells you what, the contractor determines how. Then the structural engineer supervises the erection of the building by checking that the materials used are of the correct type, quality, quantity, and that the workmanship is of satisfactory nature. Then we have the quantity surveyor. Like I said, they are the ones who determine the total cost of the project. They do valuation. They approve and also prepare valuation that contractors and subcontractors would be providing based on as the project continues during the course of the project. Then, like I said, it controls the cost of the project. He also analyzes project costs and makes future predictions or forecast on the total cost the project is going to cost to the client. And we have the service engineer. These are people in charge of all service elements in the structure, such as air conditioning, ventilation, and all of that. Then estate manager, they are the ones that provide value of the property, both before construction and after. Then clerk of works. The clerk of works is employed by the client to be his representative on site under the direction of the structural engineer or the architect. So the idea is to have someone representing the client who has integrity, ability, and vigilance, such that he ensures that they are doing a good job. So sometimes the clerk of work may be resident on site or he may not, and then the architects or the structural engineer do like a division of power, whereby they grant him enough authority to be able to carry out some tasks, such as is mentioned here, checking contract drawings, inspecting materials, making record of labor, and all of that. Then we have the contractor. The contractor is the one that is responsible for erection of the structures according to various codes and specifications and according to the architect's drawings. Then the contractor that is sublet, or the contractor that is awarded the project, is known as the main contractor, who belongs to a large firm. And then based on different specific works that he cannot achieve or he does not have the skill and manpower to achieve, he sublets out these sections to a subcontractor. So, but he's still the one that is in charge and will be held responsible for the quality of work that is delivered, whether or not it is done by the subcontractor or by the contractor himself. Then we have the subcontractor. The subcontractor is the one that is selected by the main contractor to carry out specialized tasks, or maybe nominated by the architect or the structural engineer at the point, or the client at the point where he's nominated by either of these three parties. It becomes a nominated subcontractor, not just a subcontractor. So their functions: they can advise the architect and contractor, they have to perform their work to the client's satisfaction and all of that. Then we have suppliers. These are people who deliver raw or manufactured materials that will be used in a construction project. So we said the materials can be delivered right from the source or from the point of manufacture or from a builder's merchant. Maybe you as a contractor, you already have specific merchants that you work or you've partnered with, or from a materials agent. But usually bulk materials like sand and stone are gotten from the source, while manufactured materials are usually gotten, like joinery. We're talking about screws and all of that are gotten from the manufacturer. So we can also have a nominated supplier, which is someone that an architect or the client recommends. The function of the supplier, you have to mention to the contractor if the material you're supplying requires a specialized storage. You're also to deliver the quantity and quality of material that was agreed upon with specific delivery details as agreed upon with the contractor. Then you have to submit a competitive quotation of your supply of materials and advise the architect or the engineer on the stability of whatever material they're asking to be delivered to achieve whatever specific performance requirements they want. Then we have planning stages involved in the construction process. We said planning is carried out during the preparation. There are different types of planning stages. There's the pre-tender planning, there's the pre-contract planning, and there's the contract planning. So pre-tender planning is the one that is carried out during the preparation of estimate stage. And this preparation of estimates is as a contribution to the tender or bid. So we've heard, oh, this project, they've opened it out that we want to build a 12-story building. And now they're telling everybody, if you're interested, you need to submit a quote. You need to bid for the project by submitting your quote, and we choose the best quote or the most suitable quote and award the project to. So the preparation that is carried out before you submit the quotation is what is known as pre-tender bid. And all these activities are the activities that will be carried out during this stage of pre-tender planning. You're talking about your pre-tender report, you're talking about your decision to tender, your site visit report, your statement of method, estimate build-up. I also advise that you do not just read it here and actually check up what they mean, because sometimes in the past questions, he tells you to expatiate. I've seen in the past question where he said expatiate on statement of method and site visit report. So you need to actually understand what each of these processes mean and what is actually done during each of the process. Like I can say for statement of method is where you decide how exactly you're going to execute the project. Then site visit report, this is the initial visit where you're trying to figure out your location layout, the design, the site layout, and all of that. So you need to build up on that on your own. Then we have pre-contract planning. This occurs after you've been awarded the project. The planning that you do before execution of the project is known as pre-contract planning. So here you have your pre-contract meeting, you have your pre-contract checklist. For pre-contract checklist, you have your organizational structure. Then you have site layout planning. The site layout you've done during the pre-tender planning. You now start planning for it on how you are going to execute it. Subcontract orders, this is where you make your orders. Then you have your requirement schedules. Again, requirement schedules is very important. There are 5 requirement schedules: labor resources, material, information, plants and equipment, and subcontracts supplier. Please read these requirement schedules. It always comes out. I don't know why the man likes it. So look at each of them and what role they play. What do you use the labor resource requirement schedule for? Materials requirement schedule. All of them are simply to manage the flow of each of these constituents and how they are managed and how they plan to be managed throughout the duration of the project. So for example, if you're saying materials, we're talking about materials, we're talking about maybe sand, we're talking about concrete. So you're talking about, okay, how much materials, how much sand would I be using over the course of the project? So we can say, for example, this house, I will have something like, let me get there. This, I'll come back to that, you'll see that. Then you have master's program, budgetary control, cash flow analysis. Then you have contract planning. For contract planning, this is the planning that takes place during the building project. So talking about monthly or 6-weekly planning or weekly planning or daily planning or processing reports or updating of the progress and comparison of the budget with performance. So contract planning technique is very important. Here, for contract planning technique, you need to take notes. There's a keyword here, productivity of labor or equipment output. You need to understand what productivity of labor means and equipment output means. So productivity of labor is basically your manpower. A project cannot be successful without the manpower. I'm putting it in layman terms, but you need to research on it and be able to actually answer the question in an exam in a lot of words. So please take note of it, productivity of labor. You need to know the quantity of work and productivity of labor. So for example, if you have a productivity of labor is like 2, then you have a quantity of work of 100. You can tell that it will take you 50 days to carry out the project. That's where productivity of labor comes in. So I'll see you, then they tell you how you can, the technique you can use. So if they ask you for the techniques, contract planning techniques, to determine the duration of each task or activities, all these formulas are what you write. As I was saying, your quantity over productivity will give you your man hours. This is the one for productivity of labor, and this is the one for equipment output. So for equipment output, if you want to know how long it will take you to excavate, for example, let me use excavation. So you need to know what's the quantity to be excavated and how long does it take, or what's the output of the excavator that I am using. So if my output is 5 and the quantity to be excavated is 100 meters, for example, but that can be right because it needs to be in cube. So let's say 100 meters cube. If I divide 100 by 5, I'll be having 20 machine hours. So to determine how many machine days will be required, it will be how many machine hours divided by how many hours worked per day. So I got 20. So it will be how many hours worked per day if we are resuming from 12 to 6, 12 noon to 6 p.m. I'm just being hypothetical. This is not realistic. That's 6 hours. So that will be 20 divided by 6. If I'm saying 20 divided by 6, I'm talking about that's 3 point something. So let's say 3.2, thereabouts, 3 point something. We have machine days. So that means we're saying 3.2 days. So we're saying how many number of days per week will give you machine weight. So if we're saying we work 7 days per week, so 3.2 days divided by 7 days per week. Then after getting machine weeks or days over the number of machines, let's now say I have 2 excavators to carry out this job. It means that I'll be getting it done in less than 0 point something hours. That's the whole idea. And the same way we do it for equipment, we also have it for the human factors, that's the workers themselves. So that is very important. He usually asks it in the exam. Then, yes, I said this CPM is the last thing we're going to do. So I was telling you about requirement schedule. So this is an example of, this is the format of the requirement schedule. This is the one for labor resources. So like I said, you have laborers, bricklayers.
Sorry, I want to ask you a question.
What? Were you talking to me?
Yes, I want to ask a question.
Yeah.
Can you please go back a little? There's a dispute that is quantity over productivity. I want to ask, what's the difference between both of them?
Well, yeah.
Yes.
So one is talking about human, one is talking about machines.
Oh,
One is talking about the laborers, the second one is talking about the equipment.
Thank you.
No problem. So like I said, this is the labor resources, then this is the material schedule. You have the supplier's address, the order number, the quantity, the date ordered. So basically, it's like a record for keeping track of each of these mentioned resources, the labor resources, the materials, the information, but you have to buttress it and present it in a presentable way for the man. So you need to read up on it, and you can now draw these tables, just for the man to know that, yes, I know what I'm saying. So there's that. Then we move on to our final part, and I think the part that most of us have been looking forward to. We have the contract planning techniques. We're talking about the bar charts and the CPM method. So I won't be talking so much about bar charts because really it's not our focus. But yeah, I would just mention that bar charts is preferred by some engineers because it is easier, it's simpler, and the ease of reading, and there's an ease of revision. It shows graphically what projects tasks are behind or ahead. Then basically what you are seeing on a bar chart is the time period allocated to each project. So we know how a bar chart looks. I don't need to expatiate, but what you're saying is each project, what time periods allocated to them. So for the bar chart, it shows all of these things, such as the dates required for delivery, percentage of completion, both planned and actual, then the time relationship of various trades, but it does not show the overall project status, which is a big flaw. So you can be seeing that, oh, my excavation is supposed to be delivered in 3 days, but you do not see what these 3 days means, or the relationship these 3 days have with the rest of the project's activities or yes, the breadth of the project activities. So you do not see how if these 3 days is elapsed, it's going to affect the construction or the casting that's going to take place that's supposed to take place in 7 days time. You can't see that relationship. So you really do not know the overall effect any lag or early finish would have on the engineering project. Please, sorry, excuse me. I'm sorry. So as I was saying, I'm going to fast track it. As I was saying, yes, so that's the major flaw of bar charts. And I apologize for the interruption once again. So because of that, there had to be like an improvement, and that improvement is CPM. So CPM, its greatest strength is that you would see the effect on the entire project. You see the coordination of each project in relation to, of each activity in relation to all the other activities that are to be carried out in the project. So, like I said, it centers around its ability to indicate what tasks can be done concurrently and what tasks follow in sequence. So when there's a float time, don't let me use float time because I haven't explained. So if there's a delay, you can see what effect this delay that is happening today is going to have on a task that was supposed to happen in 7 days time, and you can mitigate whatever measures or carry out whatever measures you need to do to correct whatever effect it will be having on that activity. So, and then the part will tell you the total length of time that will be required for the project. And it also helps in the construction of or creation of the reports that you'll be submitting to the client. So I want to get into the calculation part proper. So I will state that I have done research and I realized there are, I won't say 2 schools of thoughts, but there's the way the man did it in this material and there's the way it is done on the outside. So I would not confuse us because you will arrive at the same answer. The only difference between the 2 methods is that, let me get to the calculation. I feel like if I mention this now, I will just be causing a whole lot of confusion. So for exam purposes, you always represent each task with a circle called a node. This node is, this circle that you're seeing is called a node. And each node is divided into 4. So as it's divided into 4, the first quadrant represents the event number. So is it task number 1, task number 2, task number 3, task number 4. Then the quadrant that is on the left represents your earliest finish time. And the quadrant that is on your right represents your latest start time. Then your bottom quadrant is your float time. So please take note of that. So you know exactly which number means what. Then the float that we've been talking about is basically the time each project has for execution. That's the basic definition of float. Your float time is the time each project has for execution. And it is also the difference between your earliest finish times and your latest start times. That's all about float. Then each arrow entering the node is a task that is coming. So what I mean is, look at this diagram here. You have arrow A and arrow B. These are 2 tasks that are to be running concurrently, simultaneously. Task C cannot start until task A and B that are entering this node have been completed. So it is another benefit of CPM. It serves as a guide. I hope you are still here and you are not yet lost. So for CPM, there are 2 methods of calculation, or there are 2 stages of calculation. You have your forward pass and your backward pass. Your forward pass is looking at the calculation of your earliest finish time, and your backward pass is looking at the calculation of your latest start time. So I'll be starting with your forward pass. So your forward pass, this, I hope you're following my cursor. Your forward pass starts with your earliest start time of your first activity. You will see what I mean. So I'm just going to use basic explanations. So for example, I want to wash my clothes, and at the same time, I want to iron them. But while I'm ironing them, I also want to polish my shoes. So we have 3 tasks. So I want to determine, okay, what is the plan? So if I want to wash my clothes, I'm going to be considering, okay, it will take me 1 day to wash my clothes and it will take it another 1 day to dry. So my duration is 2 days. I'm trying to explain forward pass. So if my duration is 2 days, for forward pass, so I will give the 2 explanations. The one for this material, the one I'm going to use an example, and then I will give you the other one that is out there. They will both give you the answer, but Professor Falade's method is better. And I mean better, it's more straightforward. The other one has a lot of additions and subtractions of 1. So for the outside method, when you're calculating your earliest finish time, the first day you're going to work will be your earliest start time. Your earliest finish time is equals to your earliest start time plus your duration. That's your forward pass. Your earliest finish time is equals to your earliest start time plus the duration of the activity. So according to the outside world's calculation now, if I want to wash my clothes and it's going to take me 2 days to wash and dry, that's my duration. The day I'm starting is day 1. So that means that my earliest finish time should be what? 2 plus 1, which is 3. But that doesn't make any sense because it's actually going to be 2 days because I'm counting the first day. Do you understand what I'm saying? Are you with me? You need to get it. If you get it, you get it. So I need you to be with me. Did you get that? Or I should come again?
Please come again. Please come again.
So I said, if I want to wash my clothes, it's going to take me 2 days. But the day I start is day 1. Do you understand? According to our formula, our earliest finish time would be the day I start, which is day 1, plus my duration, which is 2 days, which is 3 days. But that is wrong. The reason why that is wrong is it's going to be 2 days. Because if I start washing today, I will dry it tomorrow and it will be finished in 2 days. And that will be my earliest finish time. Do you understand? So because I'm considering the day I am starting as day 1, I need to subtract that 1 day that I am adding. Did you get that?
Okay, I got that.
Yeah, I did not get that though.
Let me come again.
Like instead of day 1, it should be like day 0.
Day 0, exactly. So that is Professor Falade's method. Professor Falade considers it as day 0. So when you consider it as day 0, you're not subtracting anyone. I think I should just leave the outside method and just teach you Professor Falade's method. The reason why I wanted to teach you the outside method is it makes sense. So we don't know if Professor Falade's method is the accepted one outside, but just for the sake of exam, he considered his first day as day 0. But in the outside world, your first day is day 1. Do you understand what I'm saying? So if your first day is day 1, you're going to wash your clothes for 2 days. So your earliest start time is day 1. That's 1. Your duration is 2 days. So that's 3. But that is wrong. So to the outside world, your earliest finish time is your earliest start time minus 1. You see what I mean? I'm just mentioning it that if you don't get it, it's fine. I will just use Professor Falade's method as an explanation. But if you get it, awesome, it works. So like I was saying, your earliest finish time is equal to your earliest start time plus duration, full stop. Then note, the earliest finish time for your preceding operation is equal to the earliest start time for your next operation. So what that means is, like I said, I want to wash and I want to dry. So let's say I had gotten an earliest finish time of 2 days. It means that for my drying, my earliest start time for drying will be the 2 days that was my earliest finish time for washing. Do you understand? Hello. Hi.
I know
Yes.
that time is
Do I need to come again? Do you get it? Should I move on? I need some sort
Please
of
come again.
come again. Okay. So I was
Come
saying
again, please.
the earliest finish time of your preceding operation is equal to the earliest start time of your next operation. So I gave an example. I said if I'm washing and then I'm ironing, if my earliest finish time for washing is 2 days, since ironing comes after, the earliest start time for my ironing will now be 2 days. I feel like all of this will make sense once we're doing a calculation. So just take note of that. Your earliest finish time is equal to your earliest start time plus duration. That's the first important thing. Then for your forward pass, your earliest finish time of your preceding operation is the earliest start time for your subsequent activity. Take note of that. So we would continue. Then the third thing you need to notice, when 2 different tasks are meeting at a node, that means you have task 3 and task 4 that were running concurrently are going to lead to task 5. You should use the largest earliest start time to calculate your earliest finish time. Those are the 3 rules for forward pass. So I would, when we're solving, I think I would write this on the whiteboard. But yeah, so that is that about forward pass. Then you move on to your backward pass. So your backward pass is trying to calculate your lowest start time. It's a latest start time rather. And your latest start time is equal to your earliest finish time minus duration. Just take note of that. Is equal to your earliest finish time minus your duration. And then your latest start time for your previous one is equal to your earliest finish time for your next one. I feel like you're not getting it well. When we reach the calculation, it will make sense. And then for your backward pass, if there are 2 tasks that are leaving from the node, you choose the one that has the lowest earliest finish time. So let's move on to an example. So that all this my earliest finish time, latest start time can make sense. So this is an example. We have 6. Is this 6? 1, 2, 3, 4, 5. Yes, we have 6 activities. We have event 1, which is the day the project starts. And the day the project starts, you are carrying out clearing and grubbing. And the duration for the activity is 2 days. Then we have project 2 to 3, which is cut and fill. The duration is 4 days. Then project 3 to 5, activity 3 to 5, which is base and grading, and continually like that. So the first thing you need to note is this 2 to 3, 2 to 4, they describe the connection between the nodes. So I will go to the example. The first one is 1 to 2. It's not written there, but it's there. So the first one is 1 to 2. So if you have here, this is your event 1, the node for event 1 and the node for event 2. So you have your arrow connecting your node for event 1 and 2. Do you understand that?
Sorry, I don't know. Is it possible to use the whiteboard or something like
Yeah,
that?
I'm going to go back, but I want you to understand
Yeah.
it. I'm going to draw it on the whiteboard. I'm going to switch to the whiteboard very soon. But I want you to see it here first. Do you understand? So what I'm saying is, this is the first event, and this is the second event. This is your project 1 to 2. So here, this is your first event, your first node, and this is your second event, your second node. So you have an arrow joining project 1 to 2. That's where that came from. Do you understand that?
Yes, I understand.
Yeah.
Then we have a second one, 2 to 3 and 2 to 4. That means your project 2 is connected to your event 3, and your event 2 is also connected to your event 4. So you have your 2 to 3 and your 2 to 4. Do you understand?
Yes, yes.
Then the next one is 3 to 5 and 4 to 5, which means that your project 3 and your project 4 are connected to your event 5. So you have 3 to 5 and 4 to 5. Then the last one is what? 5 to 6. So you have 5 to 6. That's how you draw this arrangement, because that's the first thing you need to do. If your arrangement is wrong, your calculation will be wrong. So it's based on the connection you are giving. If you are giving 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, it means everything is just going to be a straight line. Do you all get that?
Yes. Okay.
Yeah.
All right, so I will switch to the whiteboard now. And I will give you guys 2 minutes to please go and open this slide, because I'm going to obviously stop sharing. So you can follow with the question, because you need to really follow it for you to understand.
Tutor, so can you hear me?
Yes, I can.
Yeah, so I don't know if it's actually a good suggestion. I'm thinking when we're done with this example on the slide, is it possible for us to just practice one question from the past question to just
So
cement it for this particular one, because it's kind of like very tricky.
So I would really love to, but the
Okay.
problem is time. So I think what I can do is the assignment solutions. I'll send mine, so you can read that and follow that to cement it. Because this tutorial is supposed to end by 5:30, and we're already, that's 6 minutes more. Do you understand?
Yeah, I do. So like 5:30 for you, wow.
So I would solve this question and try to ensure that everybody gets this question. Then to the group, I will be sending my solutions to the assignments that you can follow.
All right.
I really broke it down. So if you can follow that, I don't think there's any question you won't be able to attempt.
All right, that makes sense. Thank you so much.
So on a blank sheet, please, again, excuse me, 2 minutes. I need to take an excuse. I'll be back. Use this one to refresh your brains, because you really need to focus for CPM. It's not hard, it's just very tricky. Once you get it, you get it.
Did we take a break, or is it my network that is
She's
hanging?
she's coming.
Oh, okay, okay, thanks. I think see, my network on the run.
Yes,
Alpha, dubs. Waiting they happen. I'm gonna help us a bit. 5 weeks.
yeah. The record call. This is the recorded, and the record am. Don't do where they know.
So with the record and me say I know if you ask for dubs, I don't understand.
When you come blue out.
I beg now, I beg. I know proud. I
Sorry, sir,
beg.
please, this is an official class. Please kindly mute yourself. Thank you very much.
Okay, sorry for that interruption. Yeah, so I'll be using the whiteboard now. Again, please pay as much attention as you can. And if you do not understand at any point, please call my attention to it. So let's go. We have the question in the slide, and I hope it's open in front of everybody so that you can follow along and see exactly what we're talking about. So draw circle. Okay, so our first one is event 1. Then we have it's connected to our event 2. Okay, then our event 2 is connected to our events 3 and 4. It doesn't necessarily have to be in that shape. So it's to your discretion, however you want to join. Just make sure the activities that are supposed to be joined together are supposed to be joined together, and the activities that are not supposed to be joined together should not be joined together. And then these two are connected to 5, and 5 is connected to 6. Okay. So we have arrow. Sorry, I'm drawing, but please ensure your arrows are straight and pointing in the direction of the tasks that is following. Okay, so in the question, what we'll be given is your duration and event number. So we have here, your duration is always written on this connecting arrow with the task name. And then your event number, if you remember, I showed you that is written in the first upper quadrant. So this is our first event. So this is event 1. Okay, then this, according to the material, the first event is what? Clearing and grubbing. So I will write C and G. Then at the bottom, my duration, which is how many days? 2 days, so 2. Then here, my duration is my event, this is second event. Then here, text, we have what? Cut and fill. So I write C and F. Then here, my duration is what? 4. Then here, we have excavate E and F. Then here, we have the duration is 2. Then here, we have 3 to 5. This is, for us, this is our number 3. And here, this is our number 4. Okay. Then here is B and G, base and grading. And the events and the duration rather is 3 days. And this one here is pause strip P, P and B. And this is also 3 days for duration. And the last one, this is our 5th event. And this one is paving. And it is 3. And the last one is our event number 6. So do we understand? I hope we all understand what this is, what we are saying, first of all.
Yeah, I do.
Okay. So our forward pass, for forward pass, what you are going to be calculating for forward pass is this right quadrant. Your backward pass will be calculating, sorry, your forward pass is calculating your left quadrant, your backward pass is calculating your right quadrant. Are you clear on that?
Yes.
So for forward pass, you will first calculate all the left quadrants. Then after calculating all the left quadrants, you will now use your backward pass to calculate all your right quadrants. So that's exactly what we're going to be doing. So as I stated earlier, I mentioned that for forward pass, we're calculating our left quadrant, and our left quadrant, according to the initial description I gave us, is your what? Your earliest finish time. So earliest finish time, I'm going to represent it with EFT. EFT is our earliest finish time. And we said our earliest finish time is equals to our earliest start time plus duration. And do we understand this?
Yes, yes.
Okay. So for the first event, according to Professor Falapi's method, you consider your first event, your earliest finish time is 0. Someone's mic is on and it's bothering me. Please, can you turn it off? Thank you. According to Professor Falabi, your earliest start time for your first event is 0. For the first day, you consider it your project start to be 0. So here I have 0. Are you with me? Do you all get that?
Yes.
So
Yes.
your day one is not day one, it's day 0. So we move on to your first activity. And I've said it, that our earliest finish time is our earliest start time plus D. But I also said you should take notes that for our number 2 now, this earliest start time that we're going to use to calculate the earliest finish time here for your event number 2, your earliest start time will be the earliest finish time of the preceding event. So here, for 1 now, for event 1, for node 1, let me use node 1, comma, our EFT is equals to 0. For node 2, our EST, that's our earliest start time, will be equals to the EFT of node 1. Do we get that? Hi.
Yeah, we'll get.
Okay. So you will now substitute this EST value in this formula of EFT. Are we clear? So for node 2, let me walk through node 2. For node 2, our EST would be the EFT of node 1, which is what? 0. So our EFT for node 2, EFT2 would be equals to the EST, which is 0, plus the duration, which is 2, which is equals to 2. Do we get that?
Sorry, no, I did not get that. Please, I'm sorry.
Okay. I'll come again. The formula for earliest finish time is equals to your earliest start time plus duration. Is that clear? The person that said you didn't get it, please, I need your responses to be sure you're following me.
Yes, I'm with you.
Okay. So I now went further to say that using node 1 and node 2 as the example, we have the current value of node 1, the EFT of node 1. I said because it's the project start, we take the EFT to be 0, giving it as 0. So the second event, the EST, that's the earliest start time for event 2, will be the earliest finish time of event 1, which is what I wrote here. For node 2, the EFT is equals to 0. For node 1, rather, the EFT is equals to 0. So for node 2, the EST of node 2 will be equals to the EFT of node 1. Did you get that?
Sorry, please. Another question.
Yes, I'm listening.
Okay, so I was thinking that why can't you just use this earliest finish time for node 2 to be EST of node 1 plus the duration, which will give us our earliest finish time for node 2. Is that not it?
And that's what I'm saying. I said the earliest start time for node 2 would be the earliest finish time of node 1. Yes. That's
that
why I
really-
wrote. That's what I wrote. I said for node 4, the earliest finish time is 0. So for node 2, the earliest start time will be the EFT of node 1.
Okay, why not put the EFT first for node 1?
What?
That's what I'm thinking.
Put the EFT for node 1.
Oh, I now went further here. See it here. I went see the EFT2 is equals to 0 plus 2 is equals to 2. Are we all clear?
No.
Is someone saying no?
We are clear, man.
Okay. So our EFT here would be equals to 2. I hope we all understand where we got the 2 from now.
Yes, ma'am.
Did someone write? There's a weird thing on my screen that popped out of nowhere. All right. So text. This is 0. Okay. And this is 2. So we are clear. So we want to move on to the next one, which is node 3. So for node 3, the EST of node 3 will be equals to the EFT of node 2. Just the same way we did 1 and 2. Do we get that? So for EFT 3 would be equals to EFT 2 plus duration. Do you understand?
Yes.
Are we all on the same page before I proceed?
Yeah.
So this one would be 6. The same thing for 4. Because the two of them, their preceding node is node 2. So for EFT4 2, EFT4 is equals to EFT2 plus D. Do we understand it?
Yes.
So this is what? 4. Then we're moving on to node 5. If you notice for node 5, there are 2 preceding nodes. So you need to choose one. So the one you select is the one that has the larger value of EFT. Do you understand?
Yeah.
So we are going to be choosing the one with the larger value, which is 6. So for EFT5, it will be equals to EFT3. And that's because EFT3 has the greater value plus duration. Is that clear?
Yes.
So this will be equals to 9. Then for the last one, I can't hear what you're saying. You're cracking.
Concerning node 5, choosing
What?
the biggest value for some.
What did
Choosing the biggest value. Can you come again?
Okay, I said when there are 2 preceding nodes, like in the situation of 3 and 4, for you to determine which value to use as the EST, earliest start time for 5, you will choose the bigger value between the 2 of them. Did you get that?
Yes. And so I want to wonder, why are you saying, think I understand that, thank you. But what you're writing here is EFT3 equals to EFT2 plus D.
Yes. So
it's not supposed to ES.
Yes,
it's not supposed to be EST.
The EST is equals to EFT3. This is the explanation for that. I wrote EST is equals to the EFT of node 1, which is what I have been saying. I said EST is equal to the EFT of the preceding node. So I'm writing it this way so you understand which value I am using.
Okay. But why is it not EST3? Why is it EFT3 equals to EFT2 plus D?
EFT is what we are finding. The formula for EFT is equals to EST plus D. Then EST of the The EFT of the node before is equal to the EST of the node after. That's what I have been saying. So for node 3 now, the node before is node 2. So the EFT of node 2 is equal to the EST of node 3. So maybe I should just put comma here. Comma. Enter. Oh, it won't make sense. Let me write it somewhere here. Okay, let me write it on the top. EFT2 is equal to EST of 3. EFT2 is also equal to the EST of 4. Then EFT3 is equal to EFT3 is equal to the EST of 5. This clear now? For the person that was asking me the question of EFT, why am I writing EFT instead of EST? Is this clear now?
EFT2 equals to EST3. Okay, tell her.
It's clear. Thank you.
Okay. So for the last one, which is EFT6, what value would we be using?
EFT5.
Thank you. So we'll be using EFT5. Please, if it is not clear, I need you to speak because it's better to get it once and for all. So our EFT5 is 9 and our duration is 3. So here will be what? 12. So we finished, this means we've completed our forward pass. So now what we want to start working on is the backward pass. Are we still? Are we clear? Can I proceed with the backward pass? Is the forward pass clear?
Yeah, it is.
All right. So for your backward pass, you will be starting from the opposite end, which is your last project. Remember that we said EFT means earliest finish time. So earliest finish time is 12 for your last project. So that means the latest start time for your last project is also that time. So let me write it in formula. It seems like you understand formula as well. So for the last node, the EFT equal to the LST, which is latest start time. Is this clear? So for this last node, your earliest finish time would be equals to your latest start time. Are we clear?
Can I go over it again?
So are you saying that the latest start time would always be the same as the?
Yes, for your last node.
Okay, for the last one. So if
That's
there
why I
was a
specified, yes.
the
For your
LST would
last
be
node.
as far as the last one. Okay.
So the earliest finish time is the same as your latest start time. So here we have 12. Is that clear? Are we all on the same page?
Yes.
So now we're going to proceed with the backward pass. So for your backward pass is equal to your EFT minus your duration. That's the formula for your backward pass. So I will write it again in words that we understand, which is formulas. I'm sorry. I want to confirm something. Okay, so let me write it here. Or maybe I should write it up here. Yeah. So for your LST, which is your latest start time, is equal to your EFT minus D. Is that clear? Is that clear?
Yes, yes.
So that means for this node 5 will be the EFT of node 6 minus the duration. Do you understand? So let me write it again. So for LST5 equal to EFT6 minus D. LST5 is equals to EFT6 minus D. Is that clear?
Yes.
On the same page. I'm really taking my time because I want us to get it. And the lack of responses are
Yeah,
wow.
apologies.
Sorry.
Yeah.
I think from now on,
Writing and
if I don't get a response, I think
Emma Pino.
Emma Benuma.
so.
Thank you so much for your time.
Thank you. So that means that for LST5, it would be 12 minus 3, which is what, 9. Is that fine? Are we on the same
Very
page?
fine, ma'am. We are on the same page now. We are on the same page.
So the next one is for, okay, so this is where the law of the back pass comes in. We have 2, okay, it's not here actually. So it's not here. So here we have LST of 5. We have gotten the LST of 5. So we need to get the LST of 3 and 4. So for LST of 3, it's going to be the EFT of what?
5.
Thank you. EFT of 5 minus D. And for 4, it's going to be what? EFT of EST of what? For LST of 4 is going to be the EFT of what?
5 minus D.
What?
EFT of 5 minus D.
Yes, yes,
Thank you. So here we have 6, and here is someone calling my attention? 6. So this is clear. So you can see the node 2. There are 2 events that are entering node 2. So you need to select one. For LST, you select the value of EFT that is smaller. Remember, for the forward pass, we chose the value that is larger. Reverse is the case. Here, you're going to pick the value that is smaller, the EFT that is smaller. So the EFT that is smaller in this situation is what?
4.
Thank you. So that means for LST of 2, equal to the EFT of 4 minus duration. So this is 4 minus 2, and this is 2. Then we have 2 minus 2 for the first one, which is what? 1. 0, sorry. So is this clear? I hope you all understand everything that we are seeing here.
Yes.
At this point, you are practically done. The hard work is past. So this bottom quadrant is simply the bigger value minus the smaller value between your left and right. So here, 0 minus 0 is what?
0.
0.
And 2 minus 2 is what?
0.
And 6 minus 6 is what?
0.
Then 6 minus 4 is what?
0. I'm sorry, 2.
Then 9 minus 9 is what? And we have 12 minus 12 is 0. So if you compare this with what is in Professor Falade's notes, it should be exactly the same thing. So there's one more thing we need to take note of. The critical path itself is the path connecting all the nodes that have no float time. Someone's mic is on. Did you get that? Or I should come again. Did you guys get that? Or I should come again?
Please come again.
I
We
said
come again.
critical path itself. This is critical path method. We've done the general path. But the critical path, Bongo, is the path connecting all the nodes that have 0 float time. If you look at all the nodes, this one does not have a 0 float time. A critical path is represented by double arrows. Let me show you what I mean. Draw arrow. So for this question, this will be our critical path. Our first event has 0, our second event has 0. So I'm going to double the arrow. Our second event has 0, our third event has 0. So I'm going to double the arrow. But our second event, our fourth event does not have 0. So this one is not a critical path. Do you understand?
Yeah.
So our third event and our fifth event, the two of them have 0. I'm going to double the arrow. And our fifth event and our sixth event, the two of them have 0. So I'm going to double the arrow. So this is our critical path. The parts where the arrow is doubled. What a critical path shows us is that these are the events that in no circumstances can there be delay. You get that?
Yes.
Yeah, we do.
So that is all about critical path method. Once you get your latest start time, your earliest finish time using your forward pass, you get your latest start time using your backward pass, then you connect all the nodes that have 0 float time, and that is the end. I will be stopping here for today, and I will be sending my solutions to the assignment to the group. With this method, you should be able to attempt any question on CPM. I hope this tutorial was helpful and we all get it. Thank you very much and have a nice day.
Thank you
Thank you
very
so
much.
much, Tutor.
Miami.